Welcome to your notes on finding the discriminant. Today we're going to learn the first part of something called the quadratic formula. And so inside the quadratic formula, which is a way to find the zeros of an equation, is something called the discriminant. And the discriminant is based off of what we already know as standard form for a quadratic equation. So underneath that, we're just going to remind ourselves what that is. And that's y equals ax squared plus bx plus c. You've seen this equation before. We've graphed parabolas using this equation, and we've gotten used to identifying the a's, the b's, and the c's. And that's all you need to be able to identify in order to find the discriminant. The formula for the discriminant is b squared minus 4ac. When you're putting this in the calculator, the reason there are parentheses here when you see this formula is you just have to make sure that the numbers you enter, especially if they're negative, are in parentheses. You don't necessarily always have to write the formula with the parentheses, but I think it'll be very helpful as you plug stuff in. So great, we've said the word discriminant, we've given you a formula, but what does that really mean? So next, what you're going to see is a table. And you're going to be calculating the value of the discriminant, and depending upon what that value looks like, it's going to tell you how many zeros or how many solutions there are. So if the discriminant, which is the b squared minus 4ac, is greater than 0, if you get a positive number, you're going to end up with 2 real solutions. And what that means is just 2 zeros, or 2 roots, or 2 x-intercepts. So if you just want to make a little sketch in your table to help visualize what's going on here, all you're going to do is just graph a parabola, and however you graph it, you're going to note that it crosses the x-axis 2 times. So the discriminant is a way to tell us how many x-intercepts our equation is going to have. So positive discriminant means 2 x-intercepts. The next case is if the discriminant is equal to 0. If you work out the formula and you get 0, you're going to have 1 real solution, or 1 x-intercept, which means if you graph the parabola, it's only going to touch the x-axis at 1 point. And the only way it can do that is if that 1 point is actually the vertex. So working out the formula, if you get 0, then you're going to have 1 x-intercept. So you can probably guess where this is going. We've had a positive case, we've had the 0 case. So now we have the negative case. And what this means is that we don't have any real solutions, or no x-intercepts, no solutions. So if you think about what the graph may look like, you'll still have a parabola type shape. It's not anything weird like that. But the parabola is either going to be located up above the axis and facing up, or you could actually have one below the axis facing down. So either one of those examples would give you no solutions because it doesn't cross the x-axis at all. So the purpose of today's practice is going to be just getting used to this formula. And then remember, this formula is going to be a part of a bigger formula called the quadratic formula. So we have 4 examples, and I really don't want you to look at all 4 of these at one time. We're just going to work them out one at a time here. You'll notice that all of the equations are written in standard form, and they're all equal to 0. So what we're basically doing is we're going to just identify the ABCs, we're going to plug those values into the discriminant formula, and then we're going to use that number to figure out how many solutions we have. So in the first one, our A is 1, that's the number in front of the x squared, our B is 12, and our C is 32. Now all we have to do is plug these into the discriminant formula. So you'll write it out first, and notice how we're just using parentheses to put all our numbers in. And then you can type it in the calculator just like that, and when you do, you get 16. Now 16 is definitely a positive number, so what that tells us is that we're going to have 2 real solutions. So both parts of those things are going to have to be present in your answer. The discriminant is 16, and then what that tells us is we have 2 real solutions. So if we were to graph that graph, it would cross the x-axis twice. In number 2, our A is 3, B is 5, and C is -2. And then you take those numbers and you plug them into the formula, being careful with your parentheses and your negatives. And then if you have a calculator where you can see what you're typing in, you can type it all in at one time, and you'll find that you get an answer of 49. Again, this is a positive answer. So this tells us that we have two real solutions. In other words, our graph would cross the x-axis 2 times. Number 3, our A value is positive 2, the B value is negative 12, and the C value is 18. Once again, you're just going to take these numbers and plug them into the formula for the discriminant. Again, being careful with your parentheses and your negatives. And as you evaluate this expression, you will see that we get 0. So this is different. 0 is not positive or negative. Remember, 0 tells us that we only have one real solution. So if you look back at your table, that tells you that the graph is just going to cross one time, and in fact, or just touch the x-axis one time, and in fact, that point would be the vertex. Our last example, we're going to do the same thing. Hopefully you're getting the hang of it. A is 5, B is negative 8, C is 9. You're going to take those numbers and again, plug them into the formula. Hopefully you'll have that memorized when you're done with your practice. And when you evaluate this one, you get negative 116. So this time we have a negative number, which tells us that we have no real solutions or 0 real solutions. What that means in terms of our graph again is that the graph will not cross the x-axis at all. It's either going to be completely above it or completely below it. All right, this concludes our video, and you may now begin the practice on finding the discriminant.